All right, in this video I'm going to go over the examples that we didn't get to in class. And so I'm going to start with question number 3, but I just want to review us briefly on 1 and 2. In 1 and 2, we're seeing that we're just trying to find the constant of variation, which happens to be the slope of the line. And slope is always the change in y over the change in x. And so in this case, we just take these two numbers and got 3, threw it back into the template, and there's your answer. So question number 3 is slightly different. We're going to be taking a look at a situation where we have 2 x's and 2 y's. So we're going to start out with this set of ordered pairs, and then we're trying to find a missing piece when one of those numbers is 10. So let's just recall that the constant of variation is going to be constant. That means the same. So the slope will be the same no matter what the numbers are. So we've just kind of forced those to be equal to each other. So when we're given 3 out of the 4 values in this template, we can easily use cross products to find it. So let's just plug the numbers in, and here you'll see that I have labeled my first set of x's and y's here, and I'm going to replace those into the template. And I can reduce that fraction if I want to. Don't have to, but I can, and it will make it a little bit easier if I do. So I'm going to then take the second x and y values and make sure that I'm matching them up. Put the x's next to the x's and y's next to the y's. Again, I'm going to change that 12 over 3 to a 4 over 1 and take my cross products. And I'm going to get the second y value that has to be 40 because they have to have the same slope. All right, so that's your answer. The next question just deals with a application. We don't have x and y this time, so we have to just understand that the placement of y in this always comes first. So t kind of takes or substitutes the place of y. So we're going to put it here and here. So the tension again is going to be that value. And we're going to set up a proportion because the constant of variation, constant means constant, the same. And so no matter what the numbers are, they're always going to have the same ratio. So we're going to plug in our numbers, and those are our first t and x values. And again, 8 divided by 2 can be changed to a 4 over 1. And then I'm going to set that equal to the second t and x values. Again, the only thing I have to be careful about is just making sure that I put the t's in the same location and the x's in the same location. Now I can do cross products. And I get t equals 20 inches. And that would be our answer. Number 5 is, again, another situation where we're comparing a person's height with their width of their shoulders. And I did have a misspelling here. I don't even want to say that word. Yeah, need to fix that. So, again, the height varies directly. So height comes first, so that takes the place of y. And so my ratio is going to be h over w. And again, this constant of variation has to be constant, has to be the same no matter what the numbers are. So if you're missing a number, you can just solve it like an equation. So here we have our cross products are going to be 17.5 times h is equal to 1,120. Divide both sides by 17.5, you get 64 inches. So in other words, a person whose shoulder width is 16 is going to be the same as is going to be 64 inches tall. And the ratio there of the height and the shoulder width is going to be the same no matter what your stature. Okay, in this next one, we're switching gears to varying inversely. Now again, let me remind you that that's just a whole different equation. And this time, the value of k is not x, or is not y over x. It's going to be x times y. If you solve for k here, you multiply both sides by x to get it by itself, and this is what you're going to get. So the constant of variation is just found by multiplying x and y. Well, this is not a situation where we have any more than 2 numbers, x and y. So x times y is going to be 11, and then it says to write the inverse variation function. So you're just going to take that variable out and plug in this variable, or this number, excuse me. And there's your answer. And the next one is similar to that. The only difference is that, you know, we're not using x and y. I want you to get kind of used to that. This is always your y variable. In this case, it really kind of doesn't matter because multiplying the order of that doesn't matter, whereas the order of a ratio or a division problem does matter. So in this case, the value of k is going to be a times b, which is 14, and you just plug that 14 back into your equation. Okay, let's take a look at question number 3. This is one where we have two sets. Again, we have two x's and two y's. So one of those variables is unknown. So again, we're going to start out with the fact that the constant of variation is going to be the same number all the way through this problem. So it doesn't matter what ordered pair you're multiplying together, they're going to always multiply out to equal the same number. So if we know the product of the first two numbers in x1 and y1 is going to be 120, then the product of x2, y2 also has to be 120. So if one of the numbers is 15, the other number has to be 8. All right, here's an interesting piece of information, heart rates and lifespans. Believe it or not, that an animal, their hearts beat at a different rate of speed, and as a result of that, it determines the span of their life. For example, in this one, it's saying that a cat lives for about 15 years and has a heart rate of 126 beats per minute, whereas a little hamster has a heart rate of 634 beats per minute. So you can tell that this guy's little heart is beating a lot faster, so its lifespan is not going to be quite as long. And it is inversely related. So the two things that we're comparing in this problem is heart rates with lifespans. And so I'm going to set up this constant of variation. I'm going to use heart rate, lifespan. So when I multiply these two numbers together, it's got to be a constant. It's got to be the same number. So for a cat living 15.2 years and heart rate at approximately 126 beats, if you multiply these two numbers, you get 1,915.2. Now, the hamster's heartbeat and lifespan have to be the same. So we know that one of those pieces is 634. So just by simply solving this equation now, you get approximately 3 years, which is about right. If any of you have had a hamster, you know they don't last too long for one reason or another. All right, so I have given you some problems to do, and hopefully you'll understand them. And if not, come see me. All right, talk to you soon.